Guys, so looking at the first page of the review sheet, looking at the first page, we're going to start with problems 1 through 3. Underline the hypothesis and circle the conclusion. So the hypothesis comes after the what? If or then. If. So if I buy a movie ticket, is the hypothesis. The conclusion would be, then I will go to the movies. Then I will watch the movie. So the if identifies the hypothesis. For the second one, I am hungry. Then identifies the conclusion. If, then. If, then. That's all we have to do for these first few. We underline the hypothesis, circle the conclusion. So the hypothesis comes after the if. The conclusion comes after the then. How are you doing?
We're doing. How are you?
Doing well.
Everybody understanding that?
What?
And we're so good we can teach this class.
Oh, that's here.
I would have a headache every
That's
day.
confidence.
Any questions on 1 through 3? All right, if we're good with 1 through 3. 4 through 6. All right, guys, so the next thing we're looking at is problems 4 through 6. 4 through 6 is to write each statement in if-then form. So when we look at the first one, an angle is 90 degrees. A right angle is 90 degrees. So if it is a right angle, then what? Then it is 90 degrees. Because we're just changing it from the original statement that's given into if-then form. So this one here, if it is a right angle, then it is 90 degrees. Then its measure is 90 degrees. Yes?
If an angle is 90 degrees, then it gives a right angle also work?
Yes, because this is a biconditional statement. It'll work either way. So this one works either way. So the same thing is true with like vertical angles. If two angles are vertical angles, then they are congruent. Because I added two angles because that's really defining what they are. Because if angles are vertical angles, we need two of them. If two angles are vertical angles, then they are congruent. And the same thing is true in number 6. Any questions on 4 through 6? Are we good with writing these in if-then form? Yes? Okay. Biconditional statements. Biconditional statement is changing the statement, dropping if and then, and using if and only if. If and only if. So we're talking about biconditional. It's talking about if and only if. If a polygon has 6 sides, then it's a hexagon. So if and only if a polygon has 6 sides, if and only if it is a hexagon. If and only if. Biconditional is if and only if. You have to have if and only if. And it cannot have if and then. It cannot have if and then. Because we're replacing if and then with if and only if. We're replacing the if and then with if and only if. So number 8, if an angle is acute, then its measure is less than 90 degrees. An angle is acute if and only if its measure is less than 90 degrees. If and only if. If and only if. So we talk about biconditional statements. We are rewriting them with if and only if. We are rewriting them with if and only if. Any questions on 7, 8, or 9? We good with these if and only if? Yes? Ten through 11. I'm only going to do one of these here. Do we want to do number 10 or number 11? I heard one of each. So our conditional statement, and it says P implies Q. Yes, that's first one. So so our P statement is it does not snow, then what? Then I will run outside. This is our conditional statement. If P, then Q. Conditional. Our converse. If what? It was if Q. Then I just changed the verbiage. I mean, because did not snow, does not snow, did not snow, same thing. It's just changing the verb tense. Yep. So we had our conditional, our converse, and then we have our inverse. Our inverse is what? If. So it's not P implies not Q, yes? So our P statement was if not snow. So the inverse of that is if it snows, then, so not Q, I will not run outside. Because our first statement was if it does not, or it does not snow. So the inverse of that is it does snow or it snows. Then, well, our original statement was I will run outside. So the inverse of that is I will not run outside. And that leads us to our contrapositive. If I will not run outside, then what? Then it snowed, and that's it. We're not going to worry about the truth values of these here. I'm not going to ask for them on the test. So you just need to be able to write the 4 statements. Our conditional, our converse, inverse, and contrapositive. You need to be able to write all 4. You need to be able to write all 4. Any questions on those there? Any questions on those there? 12 through 14, determine if inductive or deductive reasoning was used. When I rolled a dice 10 times, it came up as an even number 5 times. So there's a 50% chance of rolling an even number. This is what? Inductive, because it's an observation. I rolled the dice 10 times, so it's inductive because we can see it. It's something that is a pattern. I am 5,250 feet away from my house. Since 5,280 feet is equal to 1 mile, I am 1 mile away from home. This would be 5,280 feet. Is that a fact that there's 5,280 feet in a mile? Yes. No, there is 5,280 feet in a mile. That is a fact. So because this is a fact, we are using deductive reasoning. Facts are going to be deductive. Patterns are going to be inductive. It is a pattern, something we observe. It is a pattern. So 14, every time a firework goes off, it scares my dog. Therefore, my dog is scared of fireworks. That would be inductive. Use either detachment or syllogism to determine something from the statement. If x minus 2, if x is less than negative 2, then the absolute value of x is greater than 2. If the absolute value of x is greater than 2, then x is greater than 2. I have two statements, and I have an if and then that match, yes? So this would be syllogism, and we'd match the other two up. So if x is less than negative 2, then x is greater than 2. Doesn't make a whole lot of sense, but it does work for this here. Because we had an if and then that matched, we're going to use the law of syllogism and match up the two that were not the same. Questions on this here? Questions on 15? We go to 15? Speak now. 16. If I go to work, then I will get paid. If Tom goes to work, what happens? This is the law of detachment. So the hypothesis was if I go to work, then I will get paid. Our statement, Tom goes to work. So is the hypothesis true? Yes. So the conclusion must also be true. Tom will get paid. If a figure is a square, then it will have all right angles and four congruent sides. Figure ABCD is a square. Is this detachment or syllogism? It is detachment. Do I have two if-then statements? No. I have a statement and then something else, because I have a full statement. I have a hypothesis, conclusion. I don't have another if-then. But does this satisfy the hypothesis? If a figure is a square, ABCD is a square. So ABCD has all right angles and four congruent sides. Since ABC is a square, it satisfies the hypothesis, so the conclusion must also be true. So ABCD has four congruent sides. Law of detachment. Let's look at the last one here with law of detachment and law of syllogism. If A is equal to 6, then 3A equals 18. If 1/2 A equals 3, then A equals 6. A equals 6. If A equals 6, then A equals 6. I have an if and then from both statements, yes? So that means I can attach the other two with law of syllogism. So if 1/2 A equals 3, then what? Then, and that's our statement. Because if we have two if-then statements and one of the if matches one of the then we can use this. We drop the ones that match, line up the ones that do. Questions on these four here? Any questions on law of detachment and law of syllogism? If we're good with these here, let's look at the next part. Any questions on solving these? You will be able to use the reference sheet. You will be able to use the reference sheet. Do we need to see an example of solving one of these here? We're good with these here? We good? Okay, because really we would multiply through, giving us 12x plus 21 equals 15x plus 15. Subtract. So we'd subtract 12x from both sides, which is our subtraction property of equality. Then we would use, our subtraction property of equality, and then our division property of equality. And again, you need to include equality on all these. I didn't write them out. It is in your answer key, these here. And again, for these here, you have to write equality because we're talking about equals. There is a difference between equality and our congruency. There is a difference between the two. And for these here, again, same thing here. We have to use equality because we're talking about things being equal. Complete the statement. So this here, this was on your homework assignment. Do y'all remember doing these? Yes? Substitution property says I can substitute something in for what it matches. If AB equals 20, then AB plus CD is equal to AB is 20. So I can substitute 20 in for AB. I can substitute that value in. The symmetric property says, well, if A equals B, then B equals A. So here, it would be the measure of angle 2 is equal to the measure of angle 1. It's symmetric. We can flip it. Any questions on 21 or 22? Addition property of equality. If AB is equal to CD, then AB plus EF equals what? CD plus EF, because we can add the same thing to both sides. Multiplication property of equality. 5 times AB is equal to 5 times CD, because I can multiply the same thing on both sides. And last but not least, the transitive property. If 1 equals 2, measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, and the measure of angle 1 equals the measure of angle 3. So you're just using, so for those there that fill in the blank, you're using that property, or whatever it states, to finish the statement. You're using the property to finish the statement. Okay. I believe 26 through 29 is identify the property, yes? Because I think it says for name the following property. If PQ is congruent to ST and ST is congruent to AB, then AB is congruent to PQ. This is what? Transitive property. If you just write transitive property, it will be wrong. Of what? Well, nope. Because what are they? They are segments and they are congruent. I would like you to put segment congruency, but you're definitely going to need congruency, because if you put equality, I'm going to mark it wrong. It is not equality, it is congruency. Let's look at 27. If the measure of angle 3 is congruent to the measure of angle 3, this is our property of angle congruency. Reflexive property of angle congruency. Any questions on any of this here? We good with these here? Because again, it's applying or figuring out which of the properties lines up. The next one is symmetric property of line or segment congruency. And the last one is the symmetric property of angle congruency. So just identifying what they are. Any questions on 26 through 29? Any questions on any of these here? If we're good with these here, we'll move on to the next one. Now these here are the same as what we did already with equality, but they're just congruency. So the main difference is that we're going to have a congruent sign. So like the first one's going to be angle 1 is congruent to angle 3. So with these here, we need the congruent symbol, the equal sign with the squiggly line above it. And for segments, we have to have the line segment above it, because we're not talking about the angle anymore. we're talking about the line segment itself. We're talking about the line segment itself. Any questions on these three here? We're good with these here, finishing the statements? Yes? Okay. And I believe the last ones are these proofs here, yes? Looking at 34, 35, and 36, which one do we want to do? 34, 35, or 36? 35. Looking at 35, the first thing we need to do is, well, write our given information.
Is there anyone else?
No. So the first thing we need to do is we need to write the given statements. And what are our two given statements? Yep. Or supplementary. Because that's what's given to us. That's what it's told to us. That 1 and 2 are supplementary and 1 and 3 are supplementary. Now, since it told me that they're supplementary, it means the measure of angle 1 plus the measure of angle 2 is equal to 180. Because of supplementary angles add together to be 180. So we say the measure of angle 1 plus the measure of angle 2 is equal to 180. We can also say that the measure of angle 1 plus the measure of angle 3 is equal to 180 because the definition of supplementary angles. Supplementary angles tells me that they add together to be 180. Now I have two things set equal to 180, don't I? So that means I can set them equal to each other. So you say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3 because of the transitive property of equality. 1 plus 2 equals 180, 1 plus 3 equals 180, so I can set them equal to each other. Any questions on 1, 2, or 3? Steps 1, 2, or 3? We good with steps 1, 2, and 3? Yes?
I don't understand.
What does this equal? This one? Do they equal the same thing? So I can set these two equal to each other because they both. Yeah. Because they both equal the same thing, so they could equal each.
So you just pretty much wrote it out.
Yep. Because these are the same, yes? 180 and 180. So these should be the same. Okay. So what's our next step? Subtraction property of. So what I can do is I can subtract what from both sides? What's the same? Angle 1, yes? So I can subtract its measure, leaving me with what? The measure of angle 2 is equal to the measure of angle 3 because I subtracted 1 from both sides, the measure of angle 1. So really and both of them canceled. Any question on how we got step 4? We good with step 4? Step 5, definition of congruent angles. Well, two angles are the same measure. It means what? That they are. So angle 2 is congruent to angle. Is that what we wanted to prove? Yes, right? And that's it. That's all we have to do for this one here. Question on these here? We'll come back to those in a little bit. Now, 37 through 40, I think is the last set that we have, possibly. Yes? I mean, we have two more proofs. But when we look at this here, so the first one, angle 1 is 120. So it means the measure of angle 3 is 120. Because vertical angles are congruent. Yes, vertical angles are congruent, so they have the same measure. So for this here, 1 and 3 are both 120. What do 4 and 3 do? They add together to be what? 180, yes? Because any two angles that make a straight line are a linear pair, they add together to be 180. And what can I do? I can subtract 120 from 180, which would give us, so the other two angles are 60. So for any one of these here, these four problems, how many angles, different angle measures should I have? Two. Because here we'll have 60, 60, 120, and 120. Any questions on these here? Do we feel comfortable with these here? Yes? Those are the same. Now looking at these here, okay. Do we want to look at another geometric proof, or do you want to look at this one here? Okay. If you need to look at more proofs, come in during flex and we can go over them then. Otherwise, this one here, guys, hold on for just one moment. This one here would be a bonus on the test. This one here is going to be a bonus on the test. The way you set it up is using the fact that vertical angles are congruent. And you'd set this one up like this here and solve for x. All right, guys, you can go. Tomorrow is the first part of the test. The first part of the test. Y'all have a good rest of your day.